So instead of using tables to find the area of the curve for a standard normal curve, what we can do is also use a calculator to do this as well. So let me model how this looks like on a calculator as opposed to tables. So this question says, let's see here. So find the area under the standard normal curve to the left of the z-score that's negative 0.99. So remember, since we're doing z-scores, draw this graph of a normal curve. So remember, with the standard normal curve, 0 will represent the mean. And then we have 1, 2, basically 3 standard deviations each way. -1, -2, -3. So remember, the point of inflection is about 1 standard deviation away. So we can make a little point there, a little point there. So if I draw my curve, it kind of comes across here. And then when it hits this point here, it'll bend around, come around, come down, and it'll kind of bend again. And it'll kind of do something like that. So negative 0.99 is going to be just not quite to -1. So what we want to do is find to the left of this value here. So this is negative 0.99. So we want to find the area under the curve that's to the left of that. So we're looking for this area over here. So what we do is we use the cumulative area. So cumulative area, remember, goes from this left to right. So using my calculator, we can go to what's this we refer to again as distribution things again. This is going to be a cumulative distribution. So let me pull that up and we'll write it down. So normal cumulative distribution. So we're going to be using this normal CDF. So it's going to be doing that one. So we're going to choose number 2. Now, the lower bound is going to be to the far left. Mine does this -1e to the 99. Now, if that's not there, what we could do is just use a really small negative number. So a lot of times I'll just put a -10,000 in there, and that'll take us far enough over. So that takes us to the far left. That's going to be my left bound, which is almost like saying negative infinity, if you will. And then my upper bound is, it's going to be this z-score of negative 0.99. So remember, when we're doing z-scores, the mean is 0. The standard deviation is 1, so we don't have to change those. If I enter, we'll get this area of the curve, which, remember, the area under the curve has got to be 1. But since we're not going the whole area, this is only going to be a percentage or a portion of the area. So for this problem right here, we would have then 0.161. If we got 4 decimal places, instead of having a 0 there, that would also move up to a 1. So 0.161, if we go 4 decimal places, that would be the area of the curve to the left of the z-score. So if we look at another example, if I want to find the area of the curve left to 2.13, so again, if I draw my graph, so again, 0 is here. Then we have 1 standard deviation, 2 standard deviations, and 3 standard deviations. -1, -2, -3. The point of inflection is at 1 standard deviation, so I'll go up here somewhere. It really didn't matter. So then I'll kind of try to draw this out. So I'll be coming over here, and then I'll be kind of bending at that point, coming down, and then bending out like that. So 2.13 means we're going to be over here, just to the right of 2. So what I want to know then is the area to the left of 2.13. So what I want to know is the area from over here. So again, I can use this normal cumulative distribution. So if it's second bars, it'll do the DSTR, the distribution formulas. Number 2 is what we're looking for. Notice again, our lower bound is again still way left, so we'll use a negative 10,000 there. My upper bound is the z-score itself, which is the 2.13. Again, since we're doing standard normal, the mean is 0, the standard deviation is 1. So we put those in there, and that'll give us then the area. Notice that we are close to the area of the whole curve. So our answer would be like 0.9834. That would be the area of the curve. So if I look at this next example, find the area under the normal curve to the right of the z-score of 1.106. So again, if I draw this out, so 0 is my mean, and I have 3 standard deviations this way, 3 standard deviations this way. My point of inflection is up here somewhere, 1 standard deviation away. And then you can just kind of draw up, and then when you get to that point, you kind of bend it, and then you bend it again, and you kind of create your normal curve. So my z-score is 1.06, so that's just going to be just a shade to the right of 1. So it's going to be 1.06. What I want to know is to the right of 1.06. Okay. So what I can do using my calculator is I hit the second button and do distribution number 2. Notice that my lower bound this time is actually the 1.06. So if we put the 1.06 in there, and then my upper bound is actually to the far right, which we're going to use a big positive number, which we'll use 10,000 for that. And then notice how the mean and the standard deviation do not change. And so notice how our answer should be under 0.5 because we're not quite halfway. So we're getting this 0.144. So 0.1446 looks like. If I go 4 decimal places, 0.1446. I can never remember how the homework rounds, so we'll just see what happens there. Sometimes they want to round 3, sometimes 4. I really can never remember on that. So if we do one more example of this, we have a negative 2.16 as our z-score. So if I draw this out, here's my mean, 1, 2, 3, 1, 2, 3. And then our point of inflection is here. That helps me draw the curve. So if I draw my curve, it's going to kind of come up and then hits that point, it's going to turn, come over, turn again, out, and then you have something like that. So not a great drawing, but it'll work for us. So negative 2.16 means we're going to be just to the left of negative 2. So we're about here. But notice how this wants to go the area to the right of negative 2.16. So really what it wants is this area over here to the right. So using the calculator to do this, we can use, again, this normal cumulative distribution formula. Number 2. But notice how, again, my lower bound is actually negative 2.16. And my upper bound, again, is this big value, 10,000. So my mean is still 0 on a standard normal if we're using z-scores. And then we ended up with that. Notice that, yeah, we should be close to 1 because we've shaded almost the whole curve. So 0.9846 would be the area under the curve for that one. So if I look at one more of these, let's go again under the curve. Some point of inflection is about here. Doesn't really matter, just kind of sketch that. So I'm gonna be down low, come up, and then get it here and kind of bend it, and then bend it again, something like that. So z-score negative 1.15 would be about here. And then z-score of 1.25 would be just past 1. So what I want to know is the area between these two z-scores. So I want to know this area here. So if we do that, again, we can use our normal distribution number 2. And we can type negative 1.1, negative 1.5 as our left bound, if you will. Our left z-score and upper z-score is 1.25. So our mean and standard deviation will not change for that. And we end up within 0.825. And notice how, again, it looks like that seems reasonable because we've almost shaded the whole curve. So 0.8275 would be the area of the curve for that. So hopefully that gives you a little bit of use of how to find the area of the curve given z-scores.